Okay, Assalamualaikum warahmatullahi wabarakatuh. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. So now tutorial chapter 4.8 basis and dimension. So I hope you have tried all the questions that I gave you last week. So here I would like to show you the solution for a question regarding basis and dimension, right? Okay, start with question number 2. Question number 1 is not about basis, so I skip to question number 2. So question number 2 is about basis. Given a set S, so this set S, so how many vectors in this set? There are 3 vectors, right? So for 3 vectors, if you remember the theorem, right, in a lecture of basis and dimension, so I just write R is for to represent the vectors in the set. So I just write here let's say this is R. How many vectors? There are 3 vectors in set S. So we write R equals to 3. And then how many, what is dimension for vector space? Here vector space is in P2. P2 is vector space, a big set. Big set we call vector space. So for P2, what is the dimension for P2? Remember Pn. So to get the dimension of polynomial of degree n is n plus 1. N plus 1 is the dimension of polynomial degree n. So for P2, the dimension of P2 is equals to 3, right? So I just write n. N stand for dimension, right? So n is equals to 3. Here, number of vectors in set S is 3, and then dimension of a vector space is also 3. So here we know that when you form a matrix that represent the system, okay, is definitely a square matrix. Right? So for that, so we shall write for basis. And how many conditions for basis? Before I forget this, how many conditions for basis? We have 2 conditions, isn't it? So one is what's that? Linearly independent. If all the vectors in set S are linearly independent, right? They must be linearly independent. All vectors. I'm saying about all vectors. Focus about all vectors in a set S, right? All vectors are linearly independent. Okay, are linearly independent. And the second condition for basis, that set S, S is a spanning set. So it's spanning, S is a spanning set. So if it is satisfied for these 2 conditions, therefore S form a basis, right? So for shortcut, if the matrix that represent the system is a square matrix, okay, just jot down here. If it is formed a square matrix, okay, so to form to determine whether S is a basis for vector space P2, if you can get determinant using a technique of determinant, if determinant is not equals to 0, okay. So let's start doing this. First of all, of course, you should write in a linear combination. Right? For linearly independent and spanning set, the first step is, and don't forget that the first step is you must write in a linear combination. Okay, all the vectors in a set write in a linear combination. That means you there are some a scalar, right? Scalar C1, C2, and C2. Here, there are 3 vectors. Therefore, you should get right here as a 3 scalar. C1 multiplied with the first vector 2 plus x. Okay, this is called linear combination, right? X plus 2 x squared, C3, 4 plus 2 x squared. All right. For linear independent, here must equals to 0 because linear independent must form a homogeneous system. All right. So we start with constant 0 plus 0x plus 0 x squared. All right. This for linear independent. For second condition, spanning set. So again, you write in linear combination, but now it's not equals to 0. So it should equals to any arbitrary vector. Okay, any arbitrary vector in P2. In P2. That means in polynomial of degree 2. Okay. So let's I just write ABC, or you can write constant part, you just write K also can, any variable, all right, K plus BX plus CX square. Okay, this we call arbitrary vector in P2. Okay, the first equation is for linearly independent. The second equation is for spanning set, right? So after that, this is your first step. You should write in linear combination. All right. The second step is transform this equation into a linear system, right? So transform here into linear system. Since this is polynomial, so remember polynomial you should write all right, like term. First equation is a constant. Okay, second equation coefficient of x, and then third equation coefficient for x square. So you just follow this one to because it start with constant. So first equation should be constant. So 2C1 here, 2C1. So next one, is there any constant? No, there's no constant. Okay, for C3, yes, there is one constant here, 4. So just put here plus 4 C3 equals to 0. So I know that since R equals to 3 and also equals to 3, so I know that the matrix is a square matrix. So I choose the first one. You also can choose the second one. So I just want to choose the first equation. So equals to 0. Alright, the second equation is coefficient of x. Here C1 plus C2. Right, and then no more. All right, so equals to 0. Next one is coefficient of x square. C1, there's no coefficient of x square. C2, yes, we got 2C2, and then plus 2C3. Right, this equals to 0. Okay. All right, then write a linear system in a matrix equation. So matrix equation. All right. 2 0 4 1 here 1 and 0. So C1 here is 0, C2 2, C3 here is 2. Okay, this is coefficient matrix. So the variable here is C1, C2, C3. Okay, for this system, so variable is C1, C2, C3 equals to 0, 0, 0. Okay, done. So here the coefficient matrix is square matrix, so I would like to use determinant. You also can use arrow, it's okay. So for me, I like to use a determinant because this is easier for square matrix. So determinant of A. So A is a standard coefficient matrix. Alright, you can use to find the determinant of a matrix 3 by 3. So there are many techniques to find a determinant of 3 by 3. Okay, you can use Serres, you can use arrow. Okay, so here let me use okay, just use Serres. 2 1 0 0 1 2. Okay, 4 0 2. Add 2 columns to 1 0 0 1 2. Right. So bottom Serres is bottom minus top. Right. Bottom minus top. So bottom we got here 4. Then 0 plus 0. Right, plus 8. Minus top 0 and 0 and 0. Okay, all 0. So 4 plus 8 is 12, right? So here is not equals to 0. So what can you write your conclusion for determinant not equals to 0? Since determinant of A is not equals to 0, so S is a basis. S is a basis for P, right? So you go to next question. So you have anything that to ask me, just stop me, okay? Right, go straight to question 7. Question 7, this one also about basis. Okay. State two conditions so that S is a basis for R cube. So I mentioned in question 2, right? In question 2, there are two conditions for basis. So here, first one, all vectors. Just write here all vectors in S. So what are the vectors? 1, 2, negative, the 3 tuples, the 3 tuples. So all vectors in S are linearly independent. Okay, are linearly independent. So that first condition. Second condition, S spans R, the vector is in vector space is R3, so S spans R3. Okay, so that are two conditions for basis. Okay, so question B, determine whether the set S form a basis. So here I just check in this set S R, the number of vectors is 3. So n here, n is R cubed, right? So n equals to 3. So R equals to n. So I know that this system, right, it will form a matrix of a square matrix. It will form a square matrix. So first of all, you should write in a linear combination for linear independence and linear combination for spanning. Okay, C1 multiply with the first vector in S, right, plus C2 multiply with second vector in S, equals to, okay, for linearly independent equals to 0, 0, 0. 3 zeros. Why? Because R in R3, in R3, so 3 tuples. Next one is for spanning set. Spanning set, you must let any arbitrary vector. Okay. C3, 3, 6, negative 3. Okay, you can here like as x1, x2, x3. Okay, arbitrary vector in R3. Okay, now next one is to write a linear system. So write in linear system C1, first component, C1 plus 3C2, okay, plus 3C3 equals to 0. Then next one is for second component, 2C1 minus C2 plus 6C3 equals to 0. And then the third equation is for third component, negative C1 plus 2C2 minus 3C3 equals to 0. And then write a matrix equation. So here is 1, just take the coefficient, 3, 3, right here is 2, negative 1, 6, negative 1, 2, negative 3. Alright. Coefficient matrix here, 3 by 3 is a square matrix, right? Square matrix. Variable matrix is C1, here is C1, C2, C3. So constant matrix is 0, 0, 0. So as I mentioned, I choose linearly independent. You also can write the system based on spanning, for spanning. So just write using a determinant, technique of determinant, take A, determinant of A. So this is 3 by 3. Alright, again I use Serre's technique, Serre's method. 3, 6, 3. Alright, and then add two more columns, two more column, column 1 and column 2. Alright, so the formula for Serre's is bottom minus top. So here the answer is 3, negative 18, and then plus 12. Okay, bottom, negative 3. He's a negative 3. Yeah. Okay, then yes, that's one. And then minus top. Okay, minus top. 3 plus 12. Okay, minus 18. Top. 3. Okay, alright, done. So the answer is negative 3 plus 3, right? So it's equals to 0. So what can you say about this one? Determinant of a coefficient matrix of the system of linear equation is equals to 0. It's not a basis, right? So just write your conclusion since determinant of A is equal to 0. So S is not a basis. S is not a basis for the vector space here is R3. Okay, so I hope that one is clear. So two questions. So next question, question 9. Okay, question 9, basis for P2, right? Basis for P2, whether S is basis for P2. Alright, so first of all, you should count the R. R is, what is R? R is the number of vector in S. 1, 2, 3. So 3. And N is the dimension for P2. Dimension for P2, this is polynomial degree 2, equals to 3. So R equals to N. So I know that it must be square matrix. So again, I write a linear combination. This is basic step. So you should write x square plus 6x minus 2 plus C2 multiplied with the second vector minus 1. Here's C3, the third vector, 2x squared minus 2x plus 1. Okay, so equals to, right, first one is for linear independent, therefore 0x squared plus 0x plus 0. For spanning set, Okay, C3 2x square minus 2x plus 1 equals to, okay, arbitrary vector. So x square plus ax plus, okay, I just write here k. Okay. Okay, done the linear combination. So next step to write a linear system. Okay. C1 coefficient of x square plus the first equation is coefficient of x square. Now is coefficient of x square. So C1 plus C2 plus 2C3, all right, equals to 0. 6C1 plus 3C2 minus 2C3 equals to 0. Negative 2C1 minus C2, right, plus C3 equals to 0. Okay, done. So form a matrix equation 1, 1, 2, 6, 3, negative 2, negative 2, negative 1, 1. Okay. Then variable matrix C1, C2, C3, right, equals constant matrix here is 0, 0, 0. Okay. So take the by using determinant, because this is a square matrix. So I use determinant. So determinant, right. So here I use errors. 1, 6, negative 2, 1, 3, negative 1, 2, negative 2, 1. Add 2 columns, first and the second column. Alright. So for errors, bottom minus top. So bottom part is here is 3 plus 4 minus 12. Then minus top negative 12 plus 2 plus 6. Bottom 3, right, plus 4, okay, minus 12. So top negative 12 plus 2 plus 6. All right. So the answer is this one is negative 5 plus 4. The answer is negative 1. So negative 1 is not equals to 0. So what I can say about this one, since determinant of A is not equals to 0, so S is a basis. S is a basis for P2. Okay, S is basis for P2. Right, next question. Number 12. Number 12. Next question, number 12. Right, again, this one in the vector space in R3, vector space in R3. So does S form a basis? First step is to write linear combination. Linear combination, I know that this is a square matrix, R equals to 3, then N also equals to 3, and 3, because in R3, in R cube, so N equals to 3. So S will form a square matrix. So first of all, you should write a linear combination. Okay, plus C2, 1, 2, 3, plus C3, all right, 2, 1, 1. Okay, this equals to, for linear independent, 0, 0, 0, 0. Spanning, any arbitrary vector in R3. So you can write here x1, x2, x sub 3. Okay, done. Then write in a linear system. C1, the first equation is for first component. C1 plus C2 plus 2C3 equals to 0. C1, the second component, 2C2 plus C3 equals to 0. And then the third component is nothing here. This is 0, so just leave it that blank. Plus 3C2 plus C3 equals to 0. Then write matrix equation. 1, 1, 2, 1, 2, 1, 0, 3, 1. That is coefficient matrix. So variable matrix C1, C2, C3. Okay, constant matrix 0, 0, 0. Okay, so next one is alright, this is coefficient matrix is square matrix. So by using a technique of determinant, okay, so I'm using Serres 1, 1, 0, 1, 2, 3. Okay, here 2 plus 0 plus 6 minus 0 plus 3 plus 1 equals to 8, okay, minus 4. So 8 minus 4 is equals to 4. This is again not equals to 0. So write conclusion, since determinant of A not equals to 0, so S is basis, or S forms a basis for R cube, right? Okay, question, next question, question 13. Okay, so check R and N. So here the number of vectors in M, so I write here R, 1, 2, 3. So there are 3 vectors in set M. So how many, what is the dimension for set M? M, this is the vector space is M2 by 2, right? M2 by 2, right? The vector space. So and the dimension of vector space M2 by 2 is 4, isn't it? M by N. So M is 2, N is also 2, 2 by 2, right? So the dimension of M2 by 2 is 4. So look here, R is less than N. Can you see that? R less than N. So refer to theorem. Theorem, what theorem? So you refer to my previous slide about basis. There's one theorem, basis. If R less than N, so if R less than N, then S does not, this set, the set M, here M, this set M does not span R less than N. If R greater than N, M does not linearly independent. Okay, so you must remember that theorem. That's very useful, that theorem, for checking the result. Okay, for checking the result. But you must show how do you get that result. Okay, this one is that theorem is for you to check. Right now, R is less than N, so I know that M, this set, does not span. So does not span. So I would like to take the spanning part. So first, but you must write a linear combination of both, linearly independent and spanning set. C1 multiply with the first vector, this matrix, plus C2, second vector, 0, 0, 2, the third vector, the third matrix. This vector in terms of matrix. equals to 0, 0, 0, 0. Linearly independent. For spanning, C1 plus C2, okay, plus C3, 1, 0. Okay, arbitrary matrix. You can write here as ABCD, ABCD. Okay. Okay, next one is to write a linear system. C1, first component, first equation is for first component. So C1 minus C2, next one minus 2C3 equals 0. Okay, first one. Then second component, second entry, C1, okay, this is 0, so leave that blank, minus 2C3 equals to 0. Okay, next one, C1, also 0, just leave that blank, plus C3, this one equals to 0. Next, C1, yes, we got here 2C2, but C3 is 0, so leave it that blank. So then write in a linear, in a matrix. Here I would like to write as augmented matrix. Sorry, I want to take a spanning part because I know this does not span. So does not span out. So I must show that the working of not span. Okay. So I shouldn't take 0. 0 is for linear, linearly independent. So I must take spanning part here, the spanning part. AB, and this is C and D. Okay, C and D. Okay. Then write in a augmented matrix. So I should reduce this augmented matrix using arrow. So 1, negative 1, right, negative 2. So here 1, 0, negative 2, 1, 0, 1, 1, 2, 0. A, B, C, D. Okay. So reduce this augmented matrix until you get, can you get 0 row? Remember, does not spanning meaning the system is not consistent. So for system not consistent, there must be a 0 row in the coefficient matrix. So here I would like to zeroize all three numbers below leading 1. This is leading 1, right? So my formula should be, there are 3 formulas. So I'm going to use this one, negative 1 R1 plus R2, negative R1 plus R3, negative R1 plus R4, right? Okay. So here 1, negative 1, negative 2, 0, 1, 0, 0, 1, 3. Sorry, 0, 1, 3, 0, 3, 2. Okay. Here A, then B minus A, C minus A, then D minus A. Okay, this is the result after you perform these 3 formulas. Okay, 3 formulas. Then I would like to zeroize these 2 numbers. So by using 2 formula, okay, negative R2 plus R3 and negative 3 R2 plus R4. Okay, I'm going to use that 2 formulas. So the result is this matrix, now 1, negative 1, negative 2. Okay, this A, 0, 1, 0, nothing changed here. third one, yes, 0. This should be 0. And 3. C minus B. C minus B. C minus B. Yeah, this one it should be C minus B. C minus B. So next one is 0, 0, 2. 0, 0, 2 is D minus A. D minus A. Okay. So next one is okay. Should perform right to get a leading one. So 1 over 3 R3 leading one. So here 1, -1, -2. Alright, 0, 1, 0, 0, 0, 1, 0, 2. Okay, B minus A. Here 1 over 3. 1 over 3, C minus B. Alright, D minus A. Okay, last formula, negative, because I want to zeroize below 1. -2 R3 plus R4. So you can see the zero row in the coefficient matrix. So 0, 1, 0, 0, 0, 1. So here 0, 0, 0. So can you see that? 0 row in a coefficient matrix. So here 2A minus 3B plus D, right? 1 over 3 C minus B. Then here is -2 over 3 C minus B, okay, plus D minus A. Okay, so done. So it's clearly that M does not span vector space. Here is M2 by 2. Now why it is not span? Because there is a 0, because there is a 0 row, right? 0 row in the coefficient matrix. Okay, in other words, is the system is not consistent. Not consistent, ataupun inconsistent system. Okay, inconsistent system, right? The meaning that thus M is not a basis. M is not a basis for M2 by 2. Is that clear? Hopefully that one clear. So next question, again, question 14. Question 14, I think this one similar as a previous question. In this one is in R cube. You will get right, a system. So I just write the answer here. I hope you do the rest. First, you should write linear combination. Okay, write linear combination. Try yourself. Okay, otherwise if you must write. Try yourself. Okay, linear combination. So this linear combination you must write into two equations. First, for linear independence. Okay, for linear independence and for spanning. Okay, for spanning set. Write linear combination. Second, you should write in linear system. Yeah, linear system. System of linear equation, SLE. For a short, system of linear equation. Here, okay, I know that this is square matrix. It will form square matrix because R equals to 3 and then N also equals to 3 because R cubed. So you, for linear system, okay, you should write linear system. You can choose either linear system for linear independence or linear system for spanning set. Okay, then from this linear system, you should form a matrix. Form a matrix. Okay, you should get a matrix. Alright. Okay, form a matrix equation. Matrix equation. Then last step, determinant. Okay, find determinant. Find determinant of A. Right? If it is a basis, it is what is it is S. S is a basis. If determinant of A, determinant of coefficient matrix is not equals to 0. Okay. So you should try. Next question, alright, question number 17. Okay, question number 17. The vector space is M2 by 2. Here, R, what is the number of vectors? Number of vectors in set S. 1, 2, 3, 4. There are 4 vectors in set S. So the dimension, how about the dimension of matrix 2 by 2 is 4 also, isn't it? So here R equals to N. So R equals to N, I know that it will form a square matrix, which is 4 by 4. Okay. Give 2 conditions. One conditions, all vectors, remember, all vectors in S are linearly independent. Okay, second condition, S spans M2 by 2. Okay. Right, determine whether the set S is a basis for M2 by 2. So again, you should write in linear combination. This is a form of matrices. So write in linear combination. Right, let's do it together. C2, 1, 0, negative 1, 1. This is okay, the matrix should okay, for this one R4 and 4, so it will form a quite big matrix 4 by 4. So to get the determinant of matrix 4 by 4, you cannot use determinant, isn't it? Even though it is a square matrix, can you use determinant? No, you cannot use determinant, right? So what to do for matrix 4 by 4? How do you get determinant for matrix 4 by 4? By using arrow. Okay, you must reduce that arrow. Is it arrow? No, not arrow. Determinant by using what do you call cofactor expansion? Cofactor expansion. Okay, now I remember. Alright, this for linearly independent should get right here 0, 0, 0. Using the next one is for spanning. So for linear algebra, you should practice a lot. So practice a lot will help you to remember steps. How to give a good solution, good working. A, B, C, D. Spanning, right in arbitrary. Okay. So next step. So what to do for next step? This one, linear combination. First is for linear independent. Second, linear combination is for spanning set. So next, what to do is by write a linear system, right? So you should write linear system. C1. First equation is for first entry, right? Is for first entry. So C1 plus C2 plus C3 equals to 0. Okay, C1 okay, plus okay, C2, no C2 0. So leave it blank, C3 equals to 0. Then this one leave it blank, minus C2, okay, plus 2C4. 2C4 equals to 0. C1 minus C2 plus C3 plus 2C4 equals to 0. Okay, so now write matrix equation. The coefficient matrix is 4 by 4. 1, 1, 1, 0. Here 1, 0, 1, 0. Okay. So here the variable is C1, C2, C3, C4. Constant. Here I take equation of linear independent, so it should be 0 here. Okay, next step is by using determinant. By using determinant, right? You can use right to find a technique of determinant by cofactor expansion. Alright. To use cofactor expansion, the best you should choose the column or rows with many zero. Here I choose the third row. I choose the third row. Okay. Alright. Positive, negative. For cofactor expansion, it's alternate about the sign. Be careful about the sign. So first one is positive, negative. So this positive. Then after positive, this is negative. Negative. So negative, and then this is negative 1. Is this number, negative 1, the entry. This is a sign, sign of cofactor. And then the determinant of submatrix, you should eliminate the third row and the second column. So the submatrix here is 1, 1, 0, 1, 1, 0, and then 1, negative 1, 1, negative 1, no, 1, 1, 2, 1, 1, 2, right? Okay. Then plus 0, minus 2. This one is positive, negative, positive is negative. So the submatrix is 1, 1, 2, 1, 0, 1, 1, negative 1, 1. Okay. So now find this determinant of matrix 3 by 3. So you can choose either you want to proceed to cofactor expansion or using series, because this is 3 by 3. You can choose either one. Okay. So here I got 2. Right. I want to proceed to cofactor expansion. So this is my result. Oops. Get here one bracket. Negative 1, 2, negative 1, 1, right, minus 1, 1, negative 1. Okay. So again, the result here is, okay, I should get here 2, negative 1, minus 2, negative 1. Yeah. This also 0. Right, equals to 0. Okay, so determinant of coefficient matrix is 0. So therefore, since I just write here, since determinant of A equals to 0, so the set M and S as set S. Just now is set S, right? S is not a basis. Is not a basis for M 2 by 2. So the tedious part is to get the determinant, because this is a matrix 4 by 4. It's quite tough. Just be careful. Be careful with no error. Afraid of mistakes because it's quite big matrix. So just be careful. Okay. Right. Question 18. This is the last question. Given a matrix, again, set of matrices, the vectors in a set M is matrices. So here our number of vectors here is 4. The dimension of M2 by 2 also 4. So again, we will deal with 4 by 4 matrix. Right, so write it carefully. First, you should write in linear combination of these vectors. Here 1, 1, negative 2, 0. Write for linearly independent. 2, negative 1, 0, 4. Next one, plus C3. The third vector, 3, 0, 1, 2. Okay, C4. The fourth vector is 4, 7, 2, 1. And this is equals to 0, 0, 0, 0. Okay, done. So next, for linear combination of spanning, okay, spanning you should get arbitrary A, B, C, D, arbitrary matrix in M2 by 2. So done linear combination. So next is you're writing a linear system. C1 plus 2C2, alright, plus 3C3, okay, plus 4C4 equals to 0. Okay, so that one is first equation for first entry. Second equation is for second entry, C1 minus C2, okay, plus 7C4. Right. Next one, yeah, C3 plus C4. And last equation is for last entry, C2 plus 2C3, right, plus C4 equals to 0. So after that, you should write in a matrix equation, check the coefficient, 1, 2, 3, 4, okay, 1, negative 1, 0, 7, negative 2, yes, we got negative 2C1, negative 2C1, yeah, negative 2, 0, 1, 1, 1, 1, 0, 4, 2, 1. Okay, and variable C1, C2, C3, C4, and constant matrix 0, 0, 0. But if you choose spanning equation, the linear combination of spanning, this is not 0, 0, 0. You should write A, B, C, D. Okay. Right. Next one, get the determinant of matrix A. Why to get determinant? Because I see that this is a square matrix. So for square matrix, easy for me to use a technique of determinant. Okay, so I use determinant since this is 4 by 4. So I cannot use Serres, right, by using cofactor expansion. So here I choose along the fourth row. Right? I choose along the fourth row. Okay, we start with this one, positive, negative, positive. So this is negative, negative. So negative 0 is negative, it's just 0. Plus 4, okay, determinant of submatrix. Determinant of submatrix is this is 4 by 4. So the submatrix is 3 by 3. 3 by 3. So 1, 3, 4, 1, 0, 7, okay, negative 2, 1, 1, right? Minus 2, positive, negative, positive, this one negative, positive. Next is negative. So that's why here got negative. Okay, negative 2. So the submatrix here is 1, 2, 4. So you should eliminate the fourth row and the third column. Fourth row and third column. So here is the submatrix. 1, negative 1, 7. So negative 2, 0, 1. Okay. Plus, next one, okay, also 3 by 3. So you should eliminate the fourth row and the fourth column to get this submatrix. 3 by 3, negative 2, 0, 1. Okay, right? So here you should calculate this. Then you can get 4. I just make it shortcut. So this is a minus 2, negative 2 multiply 18 minus 3 plus negative 2 minus 7. So the answer is negative 1, 2, 3. So negative 1, 2, 3 is not equal to 0, right? So therefore, since the determinant of A is not equal to 0, so M is a basis. M is a basis for M 2 by 2. So I hope you clear about this one, basis, how to determine the given set with the vectors, okay, is a basis of a vector space. Okay, so this is the end of exercise basis, about basis and dimension. So for that, I end this class with Tasbih Kifarah and Surah Wal-As. So do you have any question before I leave?
No, madam.
No question. Okay. So for that, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Waalaikumsalam. Thank you, doctor.